Good morning, students. Before we are going to see this topic power amplifier, we have to think about this. That is, even if a message is very good, it is useful only when it reaches everyone clearly. In the same way, in electronics, a small signal may contain information, but it cannot directly drive the loudspeaker. So, we use a power amplifier as the final stage to increase the signal power and deliver it effectively to the loudspeaker. I like to add some moral concept behind this power amplifier to have better understanding. A teacher once asked two students to speak to a large crowd. The first student had good ideas but spoke so softly that only the front bench, that is front row, would hear him. The second student used microphone and speaker, so the same message reached everyone clearly. The teacher then said, "Good idea has value, but it must be strengthened and delivered properly to make an impact," which matches how a power amplifier increases the signal power before it reaches to loudspeaker. The moral behind it: talent or knowledge alone is not enough. It must be supported by the right effort and right medium to create impact. Just like a soft voice needs a microphone to reach whole audience, a small signal need power amplifier to drive the loudspeaker effectively. Come on, let's see about briefly, not in detail, briefly about power amplifier. So the learning goal: understand why power amplification is the final stage in audio system. Differentiate voltage amplifier and power amplifier clearly. Learn important performance term: efficiency, power, dissipation, distortion. Study classification based on frequency and mode of operation. Explanation: brief, not detailed explanation. Brief explanation about class A transformer coupled class A and class B push-pull operation, and some important quick points for understanding, keep in memory for examination concept. So what is power amplifier? A power amplifier is the stage that increases the power level of the signal just before the loudspeaker or low. It converts DC power from supply into AC output power, and its action is controlled by the input signal. So in a relation we can say DC power input is equal to AC power output plus losses. Why it is needed? Voltage amplifier increases only the voltage. Loudspeaker requires enough current and power. So the final stage must deliver large current with proper matching. So it's a sequence: from the source it given to preamplifier, from preamplifier it is given to voltage amplifier, the output of the voltage amplifier given to the power amplifier, the output of the power amplifier is given to speaker for better hearing. So for power amplifier, the power transistor plays the important role. Let me see the feature of the power transistor. The larger in size to handle large power, collector region made large to carry large current, heat sink is used to remove extra heat, emitter and base regions are heavily doped, input resistance is low, so it needs low input power, designed for high current handling than the normal transistor. The main concern is not just gain but power delivery and safe heat dissipation. So the comparison between the power as well as voltage amplifier with respect to the parameters: purpose. What is the purpose? The gain, collector load, coupling, input voltage, collector current and input impedance. If you are going to say purpose, the voltage amplifier raise voltage level, whereas the power amplifier raise power level. The gain is high for voltage amplifier, the gain is low for power amplifier. The collector load is high, around 4 to 10 kilo ohm, whereas for power amplifier low, around 5 to 20 ohm. Coupling, usually we have in voltage amplifier RC coupling. Here we are having transformer coupling. input voltage in few millivolt, but here it is around 2 to 4 millivolt. The collector current is about 1 milliampere, but in power amplifier it is more than 100 milliampere. Output impedance is very high, so that the current is reduced. Here the output impedance is very low, so because of that the current is high. The classification of power amplifier based on the frequency as well as based on the mode of operation. Based on the frequency, they are categorized audio power amplifier with the frequency range of 20 kHz to 20 Hz to 20 kHz, whereas radio power amplifier handles the frequency of 3 kHz to 300 GHz. Based on the mode of operation, they are categorized as Class A, that is conduction of full 360 degree cycle, Class B, conduction of 180 degree cycle, Class C, conduction of less than 180 degree cycle, Class AB, that lies between A and B, Class D for switching operation. So the important performance terms with respect to power amplifier, that is collector efficiency, that means it shows effectively DC input power is converted into AC output power, that is AC output power divided by AC average DC input power gives the efficiency of the power transformer. Power dissipation is the ability of the transistor to dissipate heat produced during the operation. Here heat sinks are used to keep the temperature within safe limit. Distortion, the change in the output waveform shape compared to the input waveform. Here the less distortion means more faithful amplification. Class A operation, collector current flows for complete input cycle, that is 360 degree. The Q point is selected in the linear region, that is generally at the center point of the low light. Hence the entire input waveform is amplified. The best choice when faithful reproduction is important. Used for small signal amplification with very low distortion. The main problem is poor efficiency and large heat loss. The Class A power flow, that is it have DC input power, that is P is equal to V into I. This power is divided into useful AC output power and transistor load loss. The useful ideas here, even without signal, Class A transistor draw current continuously, those power is so, the power is wasted as a heat. Why the efficiency is low means, the reason is transistor conduct all the time, large quiescent current is present, power is consumed even when no signal is applied. That's why this Class A amplifier have excellent quality but poor efficiency. Class A merits and demerits. The advantages are current flow for full input cycle, amplify the complete cycle, very low distortion, output faithful to the input. That are the advantage. When you are going for disadvantage, low output power, low collector efficiency, more heat dissipation, not suitable when high efficiency is needed. So transformer coupled Class A, here the collector load is replaced by transformer primary. The secondary is connected to load, usually the loudspeaker. The main purpose is impedance matching. It transfers maximum power to load. The key idea to be keep the reflected load from secondary appears in primary. The proper turn ratio helps match high collector circuit impedance to low load impedance. The efficiency improve compared to simple series fed Class A amplifier. Transformer coupled Class A amplifier detail. The construction, it consists of R1, R2 as voltage divider bias, RE gives stabilization, CE bypass the AC, transformer acts as load. Efficiency, notes mention ordinary Class A has efficiency below the transformer coupled type, and the transformer coupling can improve it to about 50% under ideal condition. No signal power loss in collector resistor, but matching higher gain DC isolation between collector circuit and load are the important need for this transformer coupled Class A amplifier. So advantage, no signal power loss in collector resistor, excellent impedance matching, high gain DC isolation is provided. Whereas disadvantage, low frequency signals are comparatively less amplified, hum noise may be introduced, transformers are bulky and costly, poor frequency response. The class B operation, biasing set out cutoff at zero signal, the collector current is nearly zero, the transistor conducts only positive half cycle, that is 180 degree. The efficiency is better than class A, but output contains only one half cycle in a single transistor arrangement. Hence, distortion is high if used alone. Class B push-pull amplifier, two identical transistors are used in class B push-pull amplifier. The input transformer gives two signals that are 180 degree out of phase. During positive half cycle, T1 conducts, T2 cut off. During negative half cycle, T2 conducts, T1 cut off. So the output transformer combines two half cycle, producing almost undistorted complete output. The arrangement improves efficiency and reduce the distortion compared to single transistor class B amplifier. So why it is better means no collector current flow at zero input. So standby power loss is much lower than class A. Due to the push-pull effect, it have efficiency of 78.5%. Higher efficiency is achieved, but crossover distortion can appear near zero crossing in practical circuit. So other classes are class AB, class C, class D. The class AB is the conduction angle is more than 180 degree, less than 360. So that only it lies between the class A and class B. Class C is conduction is less than 180 degree, very high efficiency, high distortion, mainly used in tuned RF circuits. Class D operates as a switching amplifier, very high efficiency and widely used in modern audio power system. The major, that is a beautiful comparison about all type of power amplifier with respect to conduction angle, distortion, efficiency and typical use. If you are going to have AB, class AB, see here the conduction angle is 180 degree to 360 and the distortion is very low, better than class A. It used in the audio output stage. Like that it is explained for all type of amplifier. So in order to have memory, that power amplifier, there is summary of this brief explanation about power amplifier. Power amplifier is the last stage before load. Main goal is maximum output power with acceptable efficiency and low distortion. Collector efficiency is calculated with respect to AC output divided by DC input. Heat sink improves the power dissipation capability. Class A conduct for full cycle, class B conduct for half cycle. Transformer coupling is mainly for impedance matching. Class B push-pull ideal efficiency is about 78.5. So I wind up this brief explanation about power amplifier.